So here's the deal. This FRQ is a great practice problem because it puts together the idea of integral and derivative. Okay? So I'm going to give you 15 minutes to do as much as you can with this. You can work with people and get an idea of what to do and all that. You can ask me questions, and then we'll go over it. Okay? Paying attention to what's given and what you need. Did I give you a rate or did I give you an amount? That's the big question on these. All right, so first thing we got to do is obviously read the problem. But E is what? E is the rate at which people enter. L is the rate at which people leave. So let me ask this question before we go any further. How would we find the rate of change at which the number of people in the park change? No. How do you find the rate at which the amount of people is changing in the park? If E represents the rate in and L represents the rate out. Just subtract E minus L, right? And so that's, you saw that in part C. We'll get to that, okay? Part A says how many people have entered the park. If I give you a rate at which people enter, how do I find the amount of people that have entered? The integral. So the integral from why 9 to 17? Because 9 is like 9 a.m. 9 is when the park opens, and we're going to 17 because that's how many people. That's at what time we want. So integral from 9 to 17 of e of t dt, right? That's it, because we want to know how many people have entered the park. We don't care about how many people are actually in the park. We just want to see how many people have entered. So what did you guys get for that? 6,004.270. Okay. So now it does say in part A, round your answer to the nearest whole number. So it would be 6,004 people. You could say 6,004 people have entered the park by whatever time that is. 5 p.m., right? Okay. Part B. The price of admission to the park is $15 until 5. And the price of admission after 5 is $11. How much money was collected on that day? So how do you figure out how much money is collected? You take the amount of people that enter the park and you multiply it by how much it costs per ticket, right? But it's a different price depending on what time. So we're going to say $15 is for what? From 9 to 17. So I'm just going to write this out. 15 times integral from 9 to 17 of e of t dt. Does the rate or the amount at which people exit the park have anything to do with the amount of money it's made? No. If you walk in and you stay for 5 minutes and then leave, you're still paying the same amount, right? Then what do I have to do? Plus 11 times 17 to 23, because this gives me, this second part gives me what? This gives me, just this integral gives me the amount of people that have entered over this time, and then we have to multiply that by the cost per ticket, right? So what do we get there? Now, I would personally write this in my calculator like this, but you could have said 15 times that, plus 11 times, figure that out, and then add them up. But just do it all in one sequence on your calculator. What do you get? 104. 041 point. I know, but I will interpret it in a minute. But what's point what? Nobody did it? What'd you say? Uh-oh. Some people disagree with somebody. Uh-oh. Let's see if I'm right. Or who is right based on mine. 104,048.165. Fair enough. They can't argue, because really, technically, you're supposed to round after. You round your final answer after the calculations are all done. So this, I use this number. Okay? And that's when you type this into your calculator like this, you get the actual value. So you could have an argument that you're right because you can't have 6,004.270 people enter the park and vice versa. But I get what you're saying, but we'll look at their grading rubric if we have time in a minute. But the bottom line is that is the final answer for part B. Okay. Now they might have accepted another answer. We'll talk about that in a minute. Part C. This is an interesting one. Part C says that h of t is equal to the integral from what? 9 to t of e of x minus L of x dx. What's the variable in this equation? No. T is the variable. There's your variable. These are just placeholders because you don't want to use t again. That's all it means. What does E represent? The rate of enter. L represents the rate of leaving. So what is E minus L? The rate at which the amount of people change, right? Okay. So when I take the integral of the overall rate, what do I get? An overall amount. Not necessarily the amount of people, well, yeah, because how many people did we start with at the beginning? 0. So, but if we started with another number, then it wouldn't be the amount, but it's the change of the number of people. Does that make sense? That's what H represents. So then the first question is, the value of H of 17 is this. Find the value of H prime. So let's do that real fast. H prime. Well, before we can find H prime of 17, we have to find H prime of t. We're going to learn more about this later on, but what did I do to this to get to this? Take the derivative. So that's like saying d dt of the integral from 9 to t of e of x minus L of x dx. So what did I do? I just took the derivative of both sides, right? What happens when I take the derivative of an integral? Right. So what are you left with? H prime of t equals e of, well, now I'm going to put the t in here because you'll see why later, okay? So that's H prime of t, yeah? Okay. Now we need to figure out H prime of 17, so H prime of 17 equals E of 17 minus L of 17. You guys okay with that? Okay. So how are you going to figure that out? You just plug in the functions. This is why I told you from the beginning, it's good to store these functions where? In your y list, because you keep referring back to them. So if this is y, if you put E of t in y1 and L of t in y2, you could have typed it like this. You could have said y1 of x evaluated when x equals 17, put that in parentheses, minus y2 of x evaluated when x equals 17. And that would give you your answer. Okay. Did anybody get that answer, though? What is it? 0.21 what? 281? Okay. So that's H prime of 17. So that's the first part of the question. Am I right? Negative 380.281. Good. Okay. Are we good with that? The next part is we need to interpret. It says explain the meaning of H of 17. Well, again, H represented what? A rate or an amount? Because it's the integral of a rate, it's the amount, right? So we would say H of 17 equals, what was it? 3,725? Okay, so we would say, therefore, when t equals 17, this one's actually pretty easy. Because we started with 0 people in the park, and this is the change of the number of people, what would we say this number represents? The amount of people in the park. When t equals 17, there are 3,725 people in the park. You good? That is the meaning.
You have to include that it's the rate, or it's the change of people in the park.
I think both would work, but this is more accurate because we do know there were no people in the park. If there were 10 people in the park at the beginning, this is the wrong answer. We'd have to say there are 3,725 more people in the park at t equals 17 than there were when t equals 9 or whatever. All right, and the last part of part C is what does h prime of 17 represent? Well, h prime of 17, which we just figured out, is negative 380.281. We can understand what h prime is by looking at what h prime of t is. H prime of t is a rate in minus a rate out. What does that mean? It's the overall rate, right? So in other words, since this value is negative, what are we saying? There's more people leaving than going in, right? So this implies when t equals 17, the amount of people in the park is what? Decreasing. No, this is, what is this? It's a rate. It's not an amount. Decreasing at a rate of 380.281. What's the units? People per hour. Okay. You guys okay with that? This is your first look at this, so don't stress too much. You're going to do these probably 100 times between now and the end. Okay? All right, part D. At what time between opening and closing does the model predict that the number of people in the park is a maximum? You guys know how to find a maximum, don't you? How do you find the maximum of something? You take the derivative, but wait a minute, the derivative really implies just what? The rate. You have to find when the rate is 0, or when the rate is changing from positive to negative in a sense, right? Okay. Well, that's a good point. Does E give us the maximum amount of people? Does L, or does a combination of both? The combination of both, because the amount of people is affected by how many people have entered and exited combined, right? Okay. So, which function should we be dealing with? E, L, H, E prime, L prime, H prime. Okay, we're going to, remember, H of t is the amount of people, right? Amount of people in park. The park, right. So in order to find the maximum amount of people, we have to consider when H prime does what? Changes from positive to negative. Remember, H prime of t equals what? E of t minus L of t. So we take the rate function and we figure out the critical points of the rate function. What are the critical points of a rate function? When the rate is 0, right? So we're going to set this equal to 0. So 0 equals E of t minus L of t. So I would do another equation in your Y list where you say E of t minus L of t and then find its zeros. Do that for me real fast. When does E of t minus L of t equal 0? When t equals what? Okay, but the 46 is way out of the domain, right? So this is our only critical point? Remember, critical points occur when t equals, or when the rate is 0, it does not exist, or at endpoints, right? So what are the endpoints? T equals 9, and then the critical point here, and the end, right? What 23? Okay. Now it says, when is the amount of people at a maximum? If you used E of t minus L of t, you could observe the number line pretty easily. 9, 15.795, and 23. This is 0, and these are endpoints. So if you plug this into your y-list and graphed it, what is this value over here? You should look at your graph and determine it. Is positive, and then between here and here is negative. What does that imply about the amount of people at t equals 9? It's a what? Minimum. And this one is a maximum, and this one is a minimum. That makes sense, because how many people were in the park at t equals 9?
0.
How many people should be in the park when it closes? 0. In theory, 0, right? Now, if you want to figure out the exact values, the exact amount of people in the park, what would you have to do?
Plug it
Into what?
into the integral of dt.
I know. I'm just...
The integral of dt minus ot.
Right, which is h of t, right?
Oh, yeah.
So you're going to figure out h. If you want to know the amounts, you would figure out h of 9, which is, remember from part C, the integral from 9 to 9 of e of x minus L of x dx. And you do the same thing on all of them if you want to know each amount. But because you did the number line, you know these values are already what? Minimums, right? I was looking for the time when there's a maximum. So you'd say when t equals 15.795, the amount of people is at a maximum. What's the justification? Since h prime is greater than or equal to 0 for 9 is less than t is less than 15.795, and h prime of t is what? Less than or equal to 0 for 15.795 less than or equal to t less than or equal to 20. That was crazy, right? That's a lot of writing. That's a pretty in-depth problem, honestly. Because this number line represents h prime. So this was e minus L, and I told you to graph that. And then we observed that it's 0 here, and then it's above the x-axis and below the x-axis here. This whole equation.
Would you say like it's changing, what's it called, signs?
That gives you a relative maximum, not an absolute. Now, that's the same case here because there's only one.